My name is Cem Demircioğlu. I am going to be presenting today, and just a little bit about myself. I've been in the area for the last 15, 17 years, and before Abacus is my own company. Before developing Abacus, I was at Microsoft. I worked for them for about 3 years as a full-time employee at Partner COE and BI COE, where it's under the IT umbrella, and we were providing business intelligence solutions for the internal applications, internal clients at Microsoft. After that, I joined to a consulting company, about 600-700 people, and I was their national BI architect, flew all around the place. And then I left them right in the time frame of 2008, and since then I have my own company and running my own show. So that's me. Today I'm going to be talking about the Azure Data Factory, and this will be our agenda. And feel free to ask any questions anytime. Just jump in. And also I'm recording this session so that everybody can see after this demonstration, because we will be covering lots of code. Plus the code will be available along with my slide deck. So you can actually go tonight and start playing with it with your free subscription, which I'm going to show today. So today's agenda is going to be the introduction of the Azure platform, because I heard like some people are not really familiar with the Azure platform. It's going to be a really short presentation about the Azure platform, but you need to have some kind of foundation in order to have a grasp of the Hadoop space, the HDInsight space, and how Azure Data Factory works on top of them. And then we will go through the Azure Data Factory overview. We will have, I think, about 3 different demonstrations, starting from the most basic one, and then it will go through, and it will become a little bit more complex as we go through. We will compare and contrast the Azure Data Factory versus SSIS, because most of the people so far are really familiar with SSIS, which is SQL Server Integration Services. And that is a tool for integrating different data sources. It's an ETL tool, extraction, location, transformation. And then I'll be talking about a little bit more complex subjects when it comes to Azure Data Factory, scheduling and slicers. And then we are going to have some Q&A session, if time permits. So this is my first slide. It's about the Azure Data, not the Azure Data Factory, but the Azure Data Storage. In the Azure Data Storage, the most basic one is the Blob. And you have 2 types of blobs. One is the block blob, and the other one is the page blob. The block blobs are used for storing videos, where you need to have a chunk of space in order to store the video. On the other hand, page blobs are for random access. That's where you are going to store the data. And the whole HDFS paradigm, the Hadoop paradigm, is running on that page blob concept. 99% of the HDFS is running on that page blob. So the next thing in line is Azure Table. By the way, this is not the whole Azure platform. It's just the pieces that I usually play with. There are lots of other technologies, but for the time being, let's go through the Azure Table. It is a key value pairs NoSQL-based solution. What it means is you can store your unstructured data. What do I mean? You can store your Facebook profile information, for instance. Facebook does it really well. It has got your name, let's say your login name, and it has got a bunch of attributes, and it's super unstructured. Like, I may have just posted one entry, one news, but my friend could be posting lots of news, and they can be different types. So it's really hard to put it in a regular table, in a regular relational database. So they came up with this unstructured data store, and Azure has got one, actually a couple, and this is one of them, Azure Table. The next one in line is Query, Azure Query. I haven't used this service, but it's for processing messages. If you have lots of sensors, for instance, and you'd like to process them in a message queue base, you are going to use this particular technology. Last but not least, they also have Azure SQL Database, which is a relational database, but it looks like it's your local SQL server. It's running on premise, but it is slightly different. In other words, it's not as feature-rich as a SQL server on-prem, but it has got some other features where, for instance, you can expand its power really quickly. But there are some limitations of that particular technology as well. Like 500 GB, about 10 years ago, 500 GB was a lot. Now, my Google laptop is 1 terabyte of disk space that I have, and it's on SSD. It runs perfectly fine. But so database size is a big limitation of this Azure SQL database. So let's move on. The next one is about, I'm going to be talking about this blob, page blob. So let's move on. In the page blob, I'm going to compare the page blob versus NTFS storage. On the left-hand side, you see the Azure Blob storage. On the right-hand side, you're going to see the NTFS storage. Why do I do that? Because most of you guys are really familiar with the on-premise NTFS storage, but you may not be really familiar with or as familiar as with the Azure Blob storage. For instance, if I have Azure Blob storage on account concept, you can think about it on the NTFS. It is your appliance, your SCSI drive, your network distributed drives. If you think about the containers, then you can think about on the storage side your physical hard drive, your C drive, your D drive, or whatever the drive is. If you think about the blob gets a little bit complicated, but in essence, it is a disk partition plus your file. So think about it that way. It's your disk partition plus your file. Those are the things, two things. Oh, by the way, container is the physical hard drive. It's not the partition. I'm sorry, I mixed that up. The partition is at the blob level. So those are the concepts that you may need to be familiar with. And here's the way that you access any kind of cloud-based resource. This includes IBM software. This includes Amazon EC2 S3. This includes Azure Blob storage. You first type your account name, storage account name, and then blob.core.windows.net. And then you need to tell where the heck is your container. I'm going to say my container. And then you need to say, OK, under this container, where the heck is my file? So right at the end, you see the my blob over there. It's your file. That's out there.
Quick question.
Yeah.
So the container is a virtual entity or is a real drive in the rack?
It is it's a virtual entity, but it is not a physical thing, but it's a logical drive, you can say. You can think about it that way. I will show you how it looks like in Azure Explorer, and then you will have an idea. So now let's talk about the Azure Data Factory. It is an ETL as a service offering of Microsoft to orchestrate your on-premise and on-the-cloud jobs. So what it promises is going to be merging all your heterogeneous sources and orchestrating them, and either processing them through HDInsight or through whatever you want, and push the data to wherever you like to push them. It is really potentially what I would say ADF could potentially open up the cloud for the masses. The reason behind it is it makes it so easy to develop something and then to push it to cloud, to bring it back from cloud, to process on the cloud. All these things, inherently, it is really difficult. Even on the Azure platform, it was really difficult before the ADF timeframe. Why it was difficult? It is because the minute you go up to the cloud, first going up to the cloud is a task. SSIS can do that, but SSIS is just one. You need a server to do that type of an operation. Running server, you need to, in order to make that operation. The second thing is processing the data. For instance, SSIS is really hard. If you try to make cloud-based processing on SSIS integration services, it's almost impossible. But with ADF, and so far there's no competitor, as far as I know, we can comment on it as well. There's no competitor. The only competitor of ADF at this point is command line tools that people come up with. So you can think about ADF as the SSIS of the cloud on steroids. And it's going to get better as we progress it. I've been working on this particular technology for the last 3 months. And by the way, the technology is pretty brand new. They released it, correct me if I'm wrong, November of 2014 for the public preview. And we are at March of 2015, so it's about a 5-month application that has been out there. But they are really progressing a lot during that period of time. I mentioned that it is offering a rich, simple end-to-end pipeline monitoring and management interface. It is offering hybrid data movement from and to on-premise servers. So it integrates your whole ecosystem. Your cloud assets becomes your regular assets. They are not anymore so distant entities. And they are going to expand their features as we progress, as they process. Yeah?
I wonder if we can visualize it because it's reflecting off of it.
I don't know how to do that.
Sure either. There's much of control. Here.
You want to dim the light
over there?
I'll work on it back here. So.
I think it's back there.
Thank you.
Let's see. Okay. So I'll go a little deeper and compare and contrast the SSIS, the SQL integration services, versus Azure Data Factory. On your left-hand side, you see the Azure Data Factory object. On your right-hand side, you see the SQL Server Integration Services object. For instance, the link services. On the SQL integration services, we call them connection managers. Whatever you think about connection managers is applicable for the link services. Each time you need to connect to a server, you need to type your connection string. That's the idea. Data sets or tables, you can think about them OLADB sources or destinations in your SQL Server Integration Services paradigm. Pipelines, activities, you can think about them. Oh my gosh, this is getting romantic. Okay, if you can think about it like.
That's perfect.
Yeah.
That's much better. Thank you.
Transformations. That's what you do in your pipelines. The pipeline scheduling is a little bit different, but it's still related to a SQL agent job, where you have your package, and then you call your package through your SQL agent job. I'm going to come to the pipeline scheduling because one of the hardest things to grasp from a developer's perspective, especially if the person is coming from the SSIS world, we are really, really inclined towards batch processing. In other words, we have the data, we press the button, and then all of a sudden, we move the data to a place, and then it's done. In the ADF world, it's not the case. I'm going to come to that scheduling portion pretty soon. Now, let's compare the entities between these two. At the bottom, you are going to see the SSIS, how it looks like. Here, I have my OLADB source. I have a transformation, which is a really simple transformation. We are driving a column. Are you guys able to see it? And then we have our OLADB destination right at the end. We have the same concept on the ADF side. We have a table, which is your OLADB source in SSIS. We have a pipeline, which can be multiple activities that you transform the data. And then we have our destination table, or destination storage model. That's whatever we are pushing it to. So these are the things that I would say if you compare SSIS versus Data Factory. Now, go back to the comparison. If I continue to do the comparison and go a little bit deeper into the architecture, these are differences. Azure Data Factory works on the cloud. In other words, you don't have a physical server running on your on-premise server, on your on-premise facilities. You have it as a service, and Microsoft takes care of it for you. On the other hand, integration services, it is a single box solution. You have to have it either as a VM somewhere, or you have to have a physical machine that's running the integration service. Azure Data Factory is the container name that holds all your pipelines, the transformations, everything. In the integration services side, we call it SSIS project. So SSIS project is equal to the ADF factory. One factory, you can think about it as one SSIS project. This is another subject that was a little bit hard for me to grasp because I was thinking, oh my gosh, in my SSIS projects, I usually have hundreds of packages. How am I going to put hundreds of things into this diagram thing? You are going to see how it looks like pretty soon. Link services are connection managers, which I just mentioned. Data factor diagram, that is your data flow tab in your SSIS chart. There is a built-in scheduling system and retry logic, which is not available out of the box in SSIS, but you can do it with SQL agents and some custom tasks. Also, you can do some incremental runs if you want to. On the integration services side, it is a little bit hard to do incremental runs unless you are implementing through custom data flow tasks. The authoring experience can be a little bit different. In other words, there is no Visual Studio IDE at this point. They have a web interface. They have an API interface. They have a PowerShell interface. They have, I think, a C# interface, since you have the web service interface. So those are the things that you can do. You can author your pipelines with when it comes to Data Factory, Azure Data Factory. Now, let's talk about a little bit more. As I told you, the Azure Data Factory is a pretty brand new application. This has been out there for just 5 months for public preview. And right now, I'm talking about the link services. You can think about the link services as the connection managers. And in the SSIS world, we have hundreds of connection managers. You can connect the analysis services. You can connect the Oracle. You can connect the IBM DB2. We have lots of options. But think about it this way. SSIS has been around, at least, it has been around for the last 10, 15 years. And it has, along the way, it matured. Right now, this is what ADF supports. But day by day, they are adding new things. So these are the sources that ADF supports. It supports, as a source, Azure Blob, Azure Table, Azure SQL Database, on-premise SQL Server, SQL Server on IaaS, which means if you have a VM running on Azure, it supports it. You can connect to it. On-premise file system, which is NTFS file system. And these are all the sources. Does this make sense? Yeah.
So a VM, SQL Server running on an Azure VM, would that be one of those types of connections?
Yeah, that's this one, SQL Server on IaaS.
Oh, okay.
Yeah.
How about SharePoint 2010 and 13?
It's not available at this point unless you expose it through the SQL Server, right? Okay. In other words, you can connect to the SQL behind it, SQL behind the SharePoint, and get the data from there. But there's no native SharePoint provider for you, so that it exposes just the objects of SharePoint. Good question. Yeah.
I was looking at this chart earlier today. I was wondering why you can't go on-premise to on-premise or IaaS to IaaS, but you can go to SQL database in between or something?
Mm-hmm. Yeah, at this point, that is the case. Certain combinations are not there. For instance, I can pull data from on-premise file system, but I cannot push the data, not push, but push a file to an on-premise file system. Azure Data Factory team is working like crazy to make it happen, but as of this point, it's not supported. There are some other combinations or other technologies they support behind the scenes, but it's not really public, so I cannot really discuss them. But for instance, one thing that I can discuss is that is not written over here, but DocumentDB. DocumentDB is one of the technologies on Azure, and according to this chart, it's not supported. But if you work on DocumentDB just a little bit, you can actually get the DocumentDB connected through ADF and get the data from ADF. So even though it looks like it is really primitive, it is really, it doesn't have lots of things to support. When you go in, you are going to find some really neat workarounds. So on the sync side, which means these are the sources, and the columns are the sinks, which means these are the places, the destinations. They support the Azure Blob, they support Azure Table, Azure SQL Database, on-premise SQL servers, and SQL Server on IaaS, which is the VM thing. And this chart is the the official support chart, but as I told you, you can actually, behind the scenes, do certain things and get your things working. So far, I've been working on this thing for the last 3-4 months, and I was not blocked by any of the limitations of this particular system. For instance, they don't support running a store procedure on SQL Server in order to pull data or push data or anything that you want to do. But there's a way to do it if you just work around a little bit. There's a workaround in order to make that happen. So.
We pull in a lot of Excel files in SSIS.
Mm-hmm.
How about here?
Excel files. Are you talking about the Excel as a CSV file or pure Excel file?
Pure Excel.
Pure Excel file, it is not supported at this point, right? It's not supported at this point, but you can always convert the Excel files to CSVs and then use them. Or what you can do is you can write your own custom .NET activity, and you can access through your Excel files that way. Like you can use your on-premise file system, pull your Excel files to the Azure, and then access through them to, but you need to write it yourself using custom .NET activity.
Okay.
The object model allows you to do that. Yeah.
So if I have data in Azure table,
Uh-huh.
I can use ADF to push it into SQL Azure, then use again ADF to push it into on-premise?
Yes, that is correct.
Okay.
Mm-hmm. Like, if you are on Azure table, you can push it to Azure Blob, you can push it to Azure table, SQL database. But if you really want to go to IaaS, then you can go up to Azure Blob and then come over to over here, or vice versa. So the combinations are pretty rich. And by the way, my client is corporate finance, corporate functions, IT, and we do finance, legal for Microsoft. So the things that we are working on are pretty complex tasks. So believe me, if I'm not going through any blockage so far, you guys are going to be fine as well. Do not think like you are being blocked by this limited configuration. So now I'm going to show you the blob-to-blob copy demonstration. This is the first demonstration. So it's going to be a little bit easy, and we'll go through a little bit deeper. So the first thing that I'm going to show you is how to get there. This is your regular visual Windows Azure. I just typed azure.microsoft.com, and this is where I click on my accounts and my management portal. If you come over here, you are not going to find Azure Data Factory. The reason why, this is the production Azure site. So if you want to play anything related to upcoming technologies, you need to go to another site. It's called portal.azure.com. It's the same thing. You are going to use the same login name and password, but it looks slightly different, and you will have a lot more options. This particular UI is going to change pretty soon, but I don't know when. But and it's going to change to this particular thing. So let's come to browse all. These are the things that I have, and I'm right now running my demo subscription. Hence, I don't have anything. Like, there's no data factory. What do I need to do? I just need to come over here, click on the plus sign, and then I need to come over to data analytics. And as you can see, there are many, many options to choose from. And depending upon what you are doing, these options are going to create a template for you. For instance, I'm in the data analytics side, and I'm interested in a data factory. So I click on this one, and here it asks for my data factory name. I'm going to cheat here and get my data factory name from my cheat sheet. ADF. This is my data factory name. Now, the second thing that you need to do is, and this is by default going to come to you, but you need to select a resource group. My default resource group is this particular one, and I need to change it to the MSDN one so that I don't get charged. And then the subscription name is the MSDN one again. So, and I click on create. And here it is working a little bit. Now, while it's working, I'm going to show you something else. As I mentioned before, Azure Data Factory has got lots of interfaces to develop. It doesn't have the Visual Studio ID that we are all used to, which is really cool. I love it, by the way, because it gives you a different perspective, and it makes things a lot easier for me to check in, check out, like the paradigms of, think about the paradigms of SSIS, how hard it was to version control. Somebody was checking in the whole project, and then you didn't know what was changed and what particular thing. Hopefully, in ADF world, it's going to change. So this is the PowerShell interface. So far, I was showing you the UI interface, which everything can be done, but also they have the PowerShell scripting interface. Not the scripting interface. It is these are the PowerShell scripts that I'm running. I used to run. Now I'm not running, but I can run them and get the same thing. For instance, here I set my resource group. Here I set my factory name, my data factory location, my storage account name, my file name, my container name, and these are related to my storage account key, my password, everything. And here I set my subscription. Right here at the bottom, you are going to see, I don't know how easy is it to see, which I can do some zoom in. Are you guys able to see behind us? But this line, this particular line, is exactly the same as what I did just a minute ago on the UI. So depend upon your flavor, depend upon your preferences. You can either go through the PowerShell. By the way, this is just Notepad++. What I used to do was just copying and pasting the PowerShell scripts over here and be done with it. But now you don't even need to go through the PowerShell because UI supports it, which is really nice. I like it. So I created my Azure Data Factory. It's done. It's right over here. But let's go through the UI to get to it. I click on all, browse all, and I click on Data Factories. And here's my ADF demo move data. So I double click on it, and this is what you're going to get. So the left side is for, you can think about your ID, your integrated development environment, the author and deploy one. The diagram one is going to show you all of your objects. Think about it, your project. This is your diagram view, is your view of your project. The link services on the right-hand side, it is your connection managers. Like how many connection managers do you have? The pipelines you have are the transformations. How many transformations are you guys doing on those pipelines? The data sets are your tables. How many tables do you have? And if you want to click on them, you can get more information about them. So now, since I don't have anything, my diagram is all empty. What I need to do is I need to click on the author and deploy and start developing something. So the first thing you do as an SSIS developer, what would you do if you are going to move data from point A to point B? Tell me. Connection managers. Yes, that's correct. And what you need to do is, since I don't have anything over here, I need to create one. And I need to click on New Data Store. And since my objects are on the Azure Blob Storage, I click on Azure Storage. And this is what you're going to get when you click on Azure Storage. It's going to ask you, hey, what's the name of it? How do you want to refer to this particular storage service? And then the type, it's going to be Azure Storage Link Service. That's your connection manager type. The connection string is really important because we are going to use our account names and account key in order to make this work. So instead of typing up all the weird things over here, what I'm going to do is I'm going to cheat a little bit and go through my demonstration. So this is already predefined connection managers, and I'm just going to cut and copy paste over here. Boom. HR Blob Store Link Service Test is my connection manager name, or link service name. And here's my account name, and here's my long super secret account key.
Are you able to substitute in different server names or whatever
Yeah.
as variables like we do with SSIS?
No. So what you're asking is, hey,
Do I have to hard code?
you do have to hard code at this point. I think you need to be aware of this. But what this gentleman is asking for is there any way to do variable parameterization? In other words, in development, I'm going to use a development account, but when it comes to production, I want to switch everything to the production account.
So directly using this interface, you can do that. But because Azure Data Factory is a service that's in this new Azure portal, as part of this, one of the value props that this new Azure portal has is what they call Azure Resource Manager template. So all the JSON that you see here can be plugged into a bigger template. That template can be parameterized. Okay. So what will happen is all these things that you see there, like account name, account key, you have substituted it with
So you be able to substitute
some placeholder.
anything in there?
Yeah, that's right. Yeah. But then you can't do it here. Here is you have to put in the value.
Something new I didn't know. So just to repeat, apparently there is a template available with respect to these pipelines, and you can do substitution based on your environment.
That's one approach, right? Other approach that we've seen a lot of customers do is they did all this JSON files, but for all those key values, they put in a placeholder, and then they use a PowerShell script to replace it right with the right value.
Okay, yeah, with an editor or whatever.
That's right.
Stream editor and just go change it.
Yeah. And then this editor that you're seeing is really brand new. I think it's just about 2 to 3 weeks old.
Yeah.
Over the next 1 month or so, it's going to be even better. So yeah, some of this will be good.
We can trust this guy. Whatever he promised, he delivered so far. So I have my JSON script. By the way, this is JSON script. How many of you are familiar? I don't know, but it is XML essentially without all the tags. It's key value pairs all the time, and or key value objects, key objects. So I click on deploy, and it's deployed. What happened behind the scenes is this is going to get updated, but I created my first link service. As you can see, it used to be 0, now it's 1, and you can see it over here. And if I click on it, you are going to see the storage type and the name of the storage. I could have done the same thing through here, this particular interface. So there are a couple ways to skin the cat. Now let's continue. The next thing that you would do as an SSIS developer, you define your connection managers. What would be the next step? Source table, maybe? So we are going to do the same thing. We are going to define our source table, which is table stock. This is our source table JSON file. Let me move this one to our UI. And how you are going to do that? We are just going to click on New Dataset, and it's going to be an Azure Blob storage dataset. And as you can see, it automatically created us a pretty nice template. And they give specific descriptions of what to put inside of those not already filled places. But again, I'm going to cheat. I will not go through this whole document. And as you can see, there are lots of parameters over here. And I'll just paste it from my site. So what are the values? The first thing that you see at the top is the name, table stock. That is my table that I'm defining on the blob storage. It's not actually a table, per se, in the sense of a SQL table. It is just a file, but I call it as a table. Because ADF can handle files as if they are tables. And the whole HDInsight paradigm is based on that. Everything is file-based. So I call it the table stock, and then the structure, I define it with this particular JSON script. Since I'm not doing anything particular at this point, I just say, okay, these are the 6 columns out there, and they are defined as strings. What I'm going to show you is the data, by the way. Data is residing over here. That's this one, MSFD stockprice.csv, and if you want to see what it looks like, I just went to, before the meeting, I went to finance.yahoo.com and brought Microsoft's stock prices for the last, I don't know, 10, 15 years. They're days, open highs, low closes, and volumes, everything out there. And I put it up there through Azure Storage Explorer. We were talking about the containers. Here are the containers. You can think about them as directories, but the difference is you cannot create more than one container. So you cannot create more than one directory. You can think about it that way. So that's why the closest thing I could think about when it comes to NTFS is a file drive is the container, like your C drive, S drive, whatever drive.
More than one container per what application per?
Yeah, I can create as many containers as I want. Like I can click on here, and I can say here I can define the container. Like if I want, I can let this container to be available to everybody in the world. As long as they type the address right, they can access to this container and all the things underneath that container.
But you just said you cannot use more than one container.
You cannot nest them.
Meaning more levels.
Exactly.
Oh.
Exactly. Nesting is not allowed. You cannot have directories and subdirectories. Think about it that way. But, which you are going to see over here, we are going to have virtual directories. It's a little bit different concept, but think about it this way. We still have the directory concept, but it's going to be a little bit virtualized with back signs. And it's not going to look the same, but it works. And that's how Linux works, so we need to bear with it. So this is my structure, my 6 columns. And here I define my location type. It's the Azure Blob location. Here's the folder path equals to container name. This is my demo container, and that's where I define it. And don't forget to put the WAC, otherwise it doesn't work. And the file name is msft.stockprice.csv. If you are doing anything serious with HDInsight, I wouldn't recommend putting anything on your root level. This is the root level of your container. Always put everything in underneath the virtual directories. But for the time being, we can get away with it, and I'll continue. So it's a text format file, and it's delimited by comma, and the row delimiter is character return. And I'm using this HR Blob link service test in order to access to it. And I'm not going to go through this particular thing at this point, but just keep this in mind that you can slice the data. So let's deploy this. In order to make the deploy, I just click on deploy, and it's successfully deployed. Let's go back real quick, and here we go. My data set my first data set is available. And let's check out our diagram. Oh, here we go. It's right up here. Now let's continue. The second one is, I'll click on data source. And I'm lazy, so I'll just clone this thing. And here is the clone of the data table stock. So what I'm going to do is take this one and move over here. My destination table, that's what I'm going to be defining. My destination table is called table stock raw data. It has got the same structure, but it is going to have a different location. It's going to be in this raw data virtual directory. And I'm going to call it stockprice.csv. Just keep this in mind. Oops. The rest is exactly the same. So come over here, go back, delete. And the last thing I need to do is deploy. If I make a mistake in JSON, let's do that mistake real quick. Oh, by the way, my tables are right here. So my input table is here, my output table is here. We are going well. And let's say I come over to my JSON script, and for some reason I accidentally put a comma and try to deploy it. It is going to say there's a validation, and it's going to instantaneously say, oh, there's a syntax error. It doesn't tell you at this point where the syntax error is, but at least you know that it's inside of the JSON file. So you can come back and delete the comma, the syntax error that you made, and then redeploy it, and everything is going to be successful. So we have now 2 things. We have our source table, and we have our destination table. Now, in between, what do we need to do? We need to have a pipeline. So how am I going to do that? I will come over to, again, table source, And this time, I'm going to click on this particular thing, the three dots, so that it expands. And I'll click on the New Pipeline tab. Here, this is the new pipeline JSON file. If you want, each pipeline is the container's name, okay? Underneath the pipeline, you need to define your activities. Like, these are your simple activities. And each pipeline can have multiple activities. Think about it in SSIS world, we had data flow charts, data flow diagrams, and we had multiple transformations in a single data flow. I had a derived column, I had a transformation, and then I was pushing the data to the destination. The same thing is true over here. You can select multiple activities, as many as you want. And here I'm going to select a copy activity. And it automatically updates the, inserts the copy activity inside of my pipeline. But I'm going to again cheat and go back to my pipeline copy task and just copy this one. And the only reason why I'm not I'm doing this is just to save time. But I will go through the elements. So here I define my pipeline name. It's going to be pipeline copy. And here's the description if you want, you can give it. Here's the activity type. This is really important. ADF is going to look for a particular activity, and it's a copy activity. And copy activity accepts, in the transformation attribute, it accepts two things. You have to define your source type, and you have to define your sink type. And that's what I'm doing. It's going to be a blob source. It's going to be a blob sink. If I go back to my presentation, let's go back to over here. I am doing the copy activity between the blob and blob. This is what I'm doing. So let's go back. Okay. And since I define my source as blob source and sink as blob sink, I'll continue with the inputs. Here's my input table that's called table stock, and my output table is table stock raw data. And here I define some policies around what to do, and there's a description. I will come to this particular section pretty soon. It's a little bit important, not a little bit, but really important, but I will skip it at this point. So let's deploy this. It is deployed. And what is happening? Now, let's look at our diagram. Ah, dang. Okay, we need to wait a little bit until our pipeline shows up. I can drink. Oh, nice. Voila. So here's our pipeline. This is exactly the same as what you do in your data flow diagram in SSIS world. I have my input table, I have my activity, and I have my output table. That is the same paradigm. It doesn't change. Now, in order to run it, what we need to do is, if I double click on this one, it started to run automatically because I define my start and end dates and my slicers, which I'm going to come pretty soon. But just be aware that my task is going to be just copying this particular thing into a virtual directory. Let's see if it's doing it. Oh, here we go. It already did it. Here's my file, the MSFT stockprice.csv, and here's my virtual directory, raw data. Is it visible over there? Raw data vac stockprice.csv is the thing that I wanted to do, and it's doing it. It's going to do multiple times, but it is doing it. And if you want to see the actual data inside of it, you double click on the file, like here. I'm doing it. And by the way, this particular application is free of charge. You can download it from Microsoft. I think it's not Microsoft. This is an open source platform. And you click on text, top 10, and here's what you get. So now let's continue. And this thing is going to run for a couple minutes for all these tasks, for all these slicers at this point. Let's continue to our presentation. So since we did the copied blob demo, now let's move on. It gets a little bit complicated now. Scheduling. In the SQL world, in SSIS world, it was super easy. You were going into a SQL agent job, and you were able to schedule whatever you want. In the ADF world, it is not that easy. So the first thing is the scheduling. You can think about scheduling as the on-off switch of your pipeline. It defines when your pipeline is going to be available. So if your pipeline is not available during that set period of time, it's not going to run. Even if everything is ready out there waiting for you, it's not going to run. So scheduling is an on-off switch, and it has to be on in order to make it run. Does it make sense? And this is the particular PowerShell script in order to make that happen. Or what you can do is, and it's an attribute of your particular pipeline. What you can do is come over here, double-click on the pipeline, double-click on the pipeline source, and right at the end, you are going to see start and end dates. So you can actually put your start and end dates over here and make your pipeline available. If your pipeline is not defined with these start and end tags, you are just going to wait, and it's not going to do anything. Believe me, I waited a lot, so just be aware of it. So now, any questions in terms of scheduling?
Yeah, how often does it run?
Huh?
How often does it run?
Good question. We are going to come there. This is just on-off switch, though.
Okay.
So it just allows you to turn on your pipeline. Everything in ADF, unlike SSIS, which is really important to understand, is for eventual consistency. Unlike in SSIS, where you do batch processing, ADF is whenever the data becomes available, I'm going to process it. And everything can have different schedules. I don't really care. You can make it work like SSIS, but I wouldn't recommend it, but you can do it that way as well. It is supported.
So I assume it's got a trigger watching table stock.
Yeah.
When there's changes, it'll activate the process, or?
It doesn't work that way. This is just the active period of the pipeline. Does it make sense? So we didn't schedule anything yet. We didn't schedule anything yet, right? That's how I would describe it. Now I'll go a little bit deeper and talk about the slicers. The scheduling is done at the slicer level. Slicer defines the execution frequency of a pipeline, and here's how it's defined. So you first say, my pipeline is going to be available between these dates, and then you need to say, okay, what is the frequency? Is it hourly? Is it daily? Is it weekly? Is it monthly? Or is it whatever? And then you need to say how often during that frequency that it's going to run. So if you say 1 in a day, then it's going to run just once in a day. If you say 2 twice in a day, or 2 over there, it's going to run 2 times in a day with 12-hour increments. If you say hourly, the same thing is true. So that is a slightly different concept. And here's another funny thing about the slicers. And you can think about the slicer as your dates. Like each and every day becomes a slice for you. And ADF, which is really cool, is aware of that situation. If your table is divided by like this, for instance, you have days, the data is coming over, you can say, hey, this is my slicer time, and the minute the time is up, it is going to pull that data for you. You don't need to do anything.
So how did you tie this code over here on the right to your pipeline, so it knows it's using this slicer?
So I'm going to show it to you just in a second.
Okay.
Just a second. In the next slide, I will show it to you. Next slide.
So frequency can be, how small can it be? Can it go to hour, minute, second?
It can go to the hours, and then if you divide it into intervals, you can go to the minutes. I don't know. Can you go frequency with the minutes? I don't think so.
The lowest you can go is 15 minutes.
The lowest is 15 minutes. Okay. Yeah. So let me go through the demonstration I thought I had the slicer thingy. I think I deleted it. Oh, dang. Let me see if I have. We did these demonstrations a lot, so here is the slide that I was missing in my other demonstration. So the slicers are defined on both your input side and your output side. So in other words, I can have my input table to be running, to have a slicer that's, let's say, an hour basis. Every hour, there's a new slicer. But my output table is going to be, let's say, a daily basis or a weekly basis. And the execution of the pipeline is going to be based on the output table. Does it make sense?
You have to control scheduling of both the taking of the data and then have a separate schedule for the inputting of the data.
No, it's not exactly that way. Do not think about the scheduling. Think about the slicing of the data. Like, I have stock updates. Let's say I'm doing, I have a system where I check my stocks every hour. But at the end of the day, I want to get the average. I don't want to run the whole thing every hour. I just want to get the average. So my input table is going to have the slices at the hourly level, but my output table is going to have the slicer at the day level. Hence, my whole pipeline is just going to run once. But it's going to pull everything with respect to that slicer. Does it make sense a little bit? I know it's a different paradigm and it is a little bit confusing, but think about it, the eventual consistency stage. It's not your batch processing where, okay, I have my data source and it's ready. I push a button and the data source becomes the target table. In the ADF world, you have your eventual consistency. Hence, your slicers becomes really important. And the next thing that I want to mention is all your scheduling is based on your output table. So you define your execution based on your output table. There's only one exception to this rule, and which is, let's say I want to run this particular thing, this particular slice. And that particular slice, the ADF knows that that particular slice has failed. It's not going to run until this particular thing is validated and it becomes ready. Does it make sense? It is really important because you are going to run into this issue really quickly the minute you start to play with the ADF. It is a different paradigm, but it works really well. Yeah?
You use the term eventual consistency
Yes.
multiple times. Sounds like that's a fundamental notion to all this. If you could elaborate on that.
Yeah, sure. Like in batch processing, everything was defined. I run my batch every night, and I have my data and it's defined, and I click on it, and everything moves from one data store and to another one. In the ADF, that's not the case. The minute the data becomes available, my pipeline starts to run if I want it to. So that's the eventual consistency. So your data might be in progress in the middle of the day. As long as your application is aware of that fact, you are good to go. Eventually, it's going to become consistent. In other words, all the data is going to come. Like, think about your SSIS world. You have hundreds of SSIS packages. They all run, and then eventually they all become consistent. The table becomes, your fact table is out there. In ADF world, that's not the case. You can actually run individual pipelines and have different schedules, have completely different schedules.
That sounds like the queuing system, through BizTalk.
Mm-hmm. Yeah,
transactions.
Exactly. It's similar. Similar to BizTalk. Yeah.
Mm-hmm. Okay.
Good question. Any other questions? So I'm going to switch back to my demonstration now and talk about the next one. So we have our file, and it's right over here. But as you can see, it's in a virtual directory, and it's not really interesting for us. Or it doesn't have the slicer concept. It doesn't have the partition concept. So let's partition this data. How am I going to do that? I have to define my the output table again. So the difference between the current data table, and this is my data table stock raw data, my output data table, is this particular thing. Here, instead of raw data vac, like here, instead of having this raw data vac stock price.csv, I have this little additional thingy over here. Data equals slice, and slice is defined as the date and time, and it's going to come from a parameter called slicer date, slice start date. And it is going to be passed using ADF. ADF is going to pass me this slice start date to me, and I'm going to format it to DD format. So it is going to have like 10, 15, 11, whatever that is. So let's do this one and then see what happens. So what I'm going to do, and why am I doing it? I would like to partition the data. I want to have the data in different folders per day basis. That's the only reason why I want to do it. So I double click on it. I say, okay, this is my whole thing. And as you can see, this is my file name and this is my folder path, which is the container name. So I'm just going to change these two lines. Leave this one over here. So the file name is going to have this particular day slice, and it's going to be defined by here. I'll delete this area and deploy it. Now everything is deployed, and what is going to happen is I'll delete this one, or let's keep it for the time being. I'm going to choose one of the slicers, for instance, 311 slicer, and I right-click on it, and I click on Run. What is going to happen is this is the slicer status and what's happening. As you can see, when I clicked on Run, it became in progress, and I can see over here what is happening. If it succeeded, how long it took to succeed, when was the last time it started. And this is the date that I'm using in my slicer, in my ADF slice start parameter, as a slice start parameter. And this is going to take about a minute, but I think it's going to run a little bit faster than that. Here we go. This is what you're going to see. I don't know if it's visible enough, sorry, but maybe I can do it like, you guys remember how to make the screen bigger?
It's fine.
Okay, as long as you can see it, great. So raw data, vac, which is the virtual directory, day equals 11. That is my partition data. That's how Hadoop works, by partitioning the data. That's why I'm doing it. This is really important for ADF to be able to comply with the Hadoop data structure. And then I say stockprice.csv. That's right out there, and it just copied it for me. So now if I want to have a couple more, what I need to do is I can come over here and run it for the next slicer. And what you're going to see is for 10. The day 10 partition is becoming available. Right now, it's not really interesting because everything is based on a single file, like this particular thing. But think about it. If this particular file was actually coming per day basis through live stock market data, then I would have had different data files per day basis, and it would have appeared automatically for me at a scheduled time. So I can run the next one just for the heck of it. I'll just leave it like this. And as you can see, even though I click on Run, since the concurrency is at this point 1, it's set to 1, it's just going to be waiting until this thing is going to be done in progress. And by the way, why this one is pending execution? It is because my slicers, my pipeline, or I'm not at this date yet. This slicer is going to be running on 3/12/2015 at 12 a.m. UTC time. One more thing about this whole slicer concept. As you can see, I just have 1, 2, 3, 6 different slicers because I just defined this particular thing, particular pipeline, for 6 days only. So if you want to define it for a longer period of time, you need to set it right over here. Just like I'll get to you. Right here. My particular slicer or my particular pipeline is just defined between 0.8 and 0.12. That's why you have just 6 different slicers. Yeah.
Yeah, I'm still confused.
You forgot?
No, I thought the source slicer would have broken that into 6. You're saying the pipeline breaks it into 6 pieces?
This is the scheduling part. Don't forget, this is your on-off switch.
Right.
So you define your on-off switch, and then you define your slicer. And slicers can be anything. It can be hourly, and it can be on both sides of the aisle. In other words, it can be on the source side, it can be on the destination
Right.
side.
So that's not here. That's in the source slicer, right?
Yes.
In the policies down at the bottom of the source slicer?
In my source slicer, let's come from here. This is my source table. And what I define is I say frequency, daily, and its interval is 1. So once in a day, you are going to have 1 file.
Right, so that interacts with the pipeline.
That is correct.
8 parameters to decide how many slices to create.
How many slices to create? Yes, that is correct. Yes.
Yeah, that's still, I get what it's doing. I don't understand how to use that for incremental updates and stuff like that.
I was just going to show you later on, but I have videos of everything and all the use cases. Incremental updates is one of them, for instance, and you can go and check out how I'm using for incremental updates. There's a slick way of doing incremental updates. Yeah.
So in the frequency of day, you have interval equals 1. If we change that to 10, would that be even intervals?
That is correct.
Okay. Just making sure it won't write 10 in one shot.
Yep. That is
correct. When I tried the copy table, I think, or copy example, and there was 2. You go from a file to a SQL Azure database, and it was 1 hour. So as soon as I turned it on, I ended up with 22 copies of the file inserted into the target table in the SQL database. Same records inserted 22 times because it was 22 hours after UTC, Greenwich, it was 4 in the afternoon. That is confusing as heck. That it operates that way.
The eventual consistency of the data is confusing. Believe me, I was in the same shoes. I totally agree with you. But it is a totally different paradigm, and it is working. That is the way to go if you want to do anything large, big data. The data lake concept is coming from the eventual consistency.
But the file name is static, right?
The file name is static,
so how do you, once you've processed the file and sliced it and inserted it, how do you get rid of it so you don't process it again?
There are ways to do it. Yeah, you can delete the files. I'll show you the hyperqueries, and you will see how am I handling that portion.
And again, if I'm using SSS, I'm in a for each loop, right? Mm-hmm. Often we will enforce date timestamps on files, and we'll record what file we've already loaded, so we don't reload the same file over and over again. I realize it's a paradigm shift. It's just something has to be written about how to do this, because I've been looking all over the ADF site trying to figure out how to do that paradigm shift and process these files, and it's confusing.
You are asking for the state, which is really easy to do in SSIS. It's a little bit confusing to do in ADF world. And there's a workaround for it, and it works. I can tell you, you can have a state, even though ADF, by nature, it's stateless. If you want to have a state, like if you're doing incremental loads, and for some reason your destination died on you, what's going to happen is, what you can do is, the minute your destination becomes alive, ADF can push the data at the next slicer, everything for you. But it's a little bit programmatically done than just dragging and dropping. But the video is out there. If you want, you can check out the video. That's what I did. That was one of the use case scenarios. So
does it provide, provide guaranteed delivery as an MSMQ?
Yes. Yes.
So it will wait. It provides.
Otherwise, it's going to not succeed. Like
correct. Either
you have in progress or failure or success.
So it provides acknowledgement of after.
Yeah.
Okay.
Yeah.
Does it forward sequence so that if you have a failure, it's not going to keep going on to the next one.
That is correct, yes.
You have to finish the one that failed before you go to the next.
And that particular feature, that's what I'm using for incremental loads.
Okay.
Exactly that particular feature is what I'm using for incremental loads. It's available at YouTube. I think it's an interesting demonstration, but I'm not doing that particular demonstration at this point. So let's move on to our next subject. So we did the blob-to-blob copy with slicers, and let's talk about the HDInsight. Okay, why ADF is important? It is because of HDInsight. What is HDInsight? HDInsight is Hadoop. The whole mumbo-jumbo about big data is Hadoop, and it is HDInsight. Microsoft calls it HDInsight. And behind the scenes, it is Hadoop distributed by Hortonworks. Hadoop has got lots of different variations, and Hortonworks is Microsoft's vendor that they interact with. Right now, ADF supports two types of HDInsight applications, or HDInsight clusters. One of them is bring your own cluster. That's called BYOC. And it is costly. Why it's costly? It is because you bring up your own cluster, and it's just staying out there idle. And the minute your ADF runs, it's going to become available for you to use it. But the flip side is bringing up a cluster takes about 20-25 minutes. So you don't need to spend that time, that 25 minutes, right in the middle of your data transformation task. So that's the cool portion. And it's flexible. You have full control over your data nodes and the name node if you want to. If you have certain applications that require Java files to be placed, you can do it. There's another one. It's called on-demand HDI clusters, which is, again, ADF has got this capability. It's not available anywhere else. It's an economical way of running HDInsight. The minute you run your pipeline, if it requires HDInsight, it is going to bring up an HDInsight cluster for you. And once it's done, it's going to just turn off that HDInsight cluster for you. In other words, you don't need to pay for extra processing hours that thing just stays idle. The disadvantage of this approach is it takes, again, 20 minutes to build that particular cluster. So, and another thing about the on-demand cluster. Let's say I have lots of pipelines, hundreds pipelines in the data factory, and I create my HDInsight cluster once at the beginning. It becomes available as long as you set your time to live period correctly. It stays alive for all of your applications, all of your pipelines. So that's the advantage of HDInsight. And the minute TTL value is passed, which is by the minute or by the hour, it's going to just die down, and you're not going to pay anything. Now, Microsoft just announced that they are going to be running HDInsight on Linux natively, which is really, really big deal, because right now all the HDInsight Hadoop clusters are running on Windows servers, which is a little bit slow, and certain applications we cannot run, and it's cumbersome to RDP and play with it. Now they just, about 10 days ago, they said, hey, we are going to support HDInsight in Linux. But ADF doesn't support it at this point. Correct me if I'm wrong, V. But I'm sure they are going to support pretty soon. What we are doing on the Windows clusters is going to be applicable for HDInsight as well. And it's cheaper, by the way. The HDInsight on Linux is 50% cheaper than HDInsight on Windows. The reason is it's right now in preview mode, and it's cheaper. Once it becomes production, I'm sorry?
Linux is free.
I'm sorry?
It's cheaper because Linux is free, right?
I wish. So now I'm going to be talking about data processing using HDI demonstration. In this demonstration, what I did was, instead of having an on-demand cluster, I created my own cluster beforehand. The reason is it's going to take 20 minutes, as I told you, in order to create one. And how do you do that? is you need to come to HDInsight Windows Azure portal. You click on Add, HDInsight, and you can click on Hadoop. As you can see, the Linux is here, but you need to subscribe to the preview program. And then you need to give your name, how many nodes do you want, confirm an admin password in order to access to the name nodes and data nodes if you want to, the storage account that it needs. If you want, you can even customize it with different HDInsight versions and the operating system that HDInsight or Hadoop is running. So I'm not going to go through that one, but I'm just going to click on this one. So this is my HDInsight cluster. What I can do is it's right now running. It has got 4 processors, 4 CPUs, 4 cores. And so what I can do is if I have a Hive query, for instance, I can, I used to be able to click on the Hive. For some reason, it doesn't allow me to do that. Weird. Anyway, so I can come over here. I can monitor this thing, what's happening. Right now, nothing is happening because there's no load on it. I can come to configuration, and what I can do is here I can connect to my cluster. And this is the feeling of how it looks like. I'm connecting, I'm RDPing into it because it took me a while to figure out what the heck is happening behind the scenes, so that you guys can see what is happening, and then you can play with your queries as well. While this is RDPing, I can go back to my demonstration. Let's see. Okay, let me continue. So the last demonstration that I'm going to be doing is in this particular directory. So the first thing I need to do is define my HDInsight link service. This is my link service name. Here's the Windows server that runs my Hadoop clusters. And if I want to see my Hadoop clusters, this is the command line that you need to click on. And these are the applications. These are the applications that by default they're installed. You can have Mahout, you can have Hadoop HDFS, HBase, Hive, Scoop is over here. Whatever you want to do. For instance, Hive, I can go to the bin directory and I can type Hive, and it's going to open up my Hive interface. It's the same as in any Linux environment, but it takes a little bit of time to get here, which I don't like. Anyway, so let's define our HDInsight link service. I will come over here, and what happens? Okay, link services, I click on that, and I click on new data source. Let's click on Azure, even though it isn't like that. Let's own it. Oops. Discard this thing. Get rid of it. Paste it over here. What I'm defining over here is the name, HDInsight. It can be anything you want. The type has to be HDInsight, bring your own cluster link service. And here's my URI for my cluster. This is my storage account, and this is the cluster name. Here I define my username and passwords. Here is the link service that it needs to use in order to put the files, the access to files. So it is successful. Now the next step, and by the way, it shows up over here. This number is going to increase pretty soon. Come on. There we go. And if I click on it, you are going to see one data source as a Blob source and one compute node as an HDInsight link service. Now let's continue. The next step that I am going to use is this one. My Hive query. This is my Hive query. It's already up there, but these are things that I need to set in order to make my Hive query run. Here's my incremental load. I drop my table if it exists, for instance, and I recreate it, and I partition by day, and I define it like, okay, it's a row delimited file, and the row delimiter is going to be carriage return, and the column delimiter is going to be comma, and this is the location of it. As you can see, it's parameterized. And this is for creating the partitions. And then what happens is I create an output table with this syntax, and I write to that output table as an overwrite, and I basically do an average of the closing based on month and year. This is really similar to your good old SQL, where I say select month and take the T date. T date is defined right at the top as a date column, right over here. And take it as a month, convert it as a month, like casting to a month, and then take it to the T date year and call it T month, T year, and just get the closings, which is a decimal 5.2 right here. I define decimal 5.2. And here's the partition. I say, hey, day equals the slicer of the day, and I group the data. What I need to do with this particular Hive query is I need to put it somewhere. And I need to put it into my Blob storage because there's no way on ADF to put it at this point. So I already did that, so I'm going to pass that section. But I'm going to show you where I refer to that thing in a minute. So the next thing I need to do is I need to create my final destination table, which is table stock fact, which you guys should remember. It's just the name of the file. And then I define my structure. It has got just 2 columns, the date and closing price. And it has got, it will have a couple more columns, but that's okay. It has got the fact price as this particular location. And this is the container name. And this is row delimiter, column delimiter. And here I define my frequency as the day, interval, and wait on externals now. So let's copy this one. New data set, Azure Blob storage, and I will overwrite this. I will deploy it. Okay. Now the last thing that I need to do, which I want to show you, is the parameterization. Do you remember I was defining an input parameter, an output parameter, and a slicer day, and they are right here. Here's my Azure Blob storage location. It doesn't have the HTTPS. It has got WASD. I don't know what it stands, but this is how you access your data. But this is your container. This is your account. And this is your virtual directory for my raw data. And process data should be coming over to the process fact price.csv. And slicer date, again, it is based on the slicer start time. And it takes the slicer start time and formats it into a DD format. And here's my Hive query. This is where I define it. It's going to be in demo container, and it's on the root directory, and hrhivequery.hql, and you can see it right over here, this one. This is the same as what I showed you just a minute ago. So I am going to take this one and put it over here. I'm going to create a new pipeline. How am I going to do that? I'll click on this guy, click on pipeline. It's going to create a draft for me. I'm not going to go through the add activity this time. I'll just copy and paste and deploy. So what happened behind the scenes is things are getting more complex, like here. I'll align it so that zoom in. So what I'm trying to do is I'll run the whole pipeline, and then I'll eventually put my data into a table stock.fact. That is the main idea. And I think I've already defined my start and end date. Let's check it out. Yes, it is already defined, start and end date. So what I do expect is, since it's already defined, it should be running at this point. As you can see, my slicers are already starting to process. And it is running. It's going to take about a minute or so. But eventually, it is going to push the data to over here. I'm going to refresh it. As you can see, what's happening behind the scenes is Hive is running the query, that's hrhivequery.hql, and trying to get the data of this particular thing. It's not here yet, but this guy. Once it is done, you are going to see not with 0 bytes, but it will have some data in it, and it's not going to be 0 bytes. I think we need to wait about a minute or so. While it's cooking, I can answer your questions. Do you guys have any questions, comments? Yeah.
So, Kevin, with this, will it automatically partition and start running parallel processes, or is it all still right now single-threaded?
No, there's no. The partitioning is. Have you seen the way that I partition the data, like here?
Right, but does it actually spin up multiple threads to start doing all the different slices? Or?
It is done at the HDInsight level, yes. HDInsight Hadoop is based on files, and they distribute the files to the data nodes.
But
and
does ADF actually start doing multi-processing to start writing out to all the different files at the same time?
ADF doesn't do anything. ADF is orchestrating the things.
Right.
HDInsight does the things, yes.
I'm talking about the pipeline process.
The pipeline process, oh, you're talking about the concurrency.
Right.
Yes, you can set the concurrency to, right now it's at 1, but you can set the concurrency to, I don't know what's the highest value, but...
I think it's 15.
50?
15. 1.5.
1.5, 15.
Okay.
So 15 concurrent operations. Is it per pipeline or?
It's per pipeline.
Per pipeline. So you can have multiple pipelines then.
Yeah,
Each can have 15.
SSIS, you can set up the concurrency there. When you have multiple paths, it'll start off all of them.
In SSIS concurrency? Okay.
Yes.
We can talk about it. Yeah.
In ETL, the general concept of data lineage tracking, is it available in ADF?
Yes, it is available in ADF, and it's really visual, and I like it. Oh, by the way, this one just completed, but if for some reason it has failed, you could have just clicked on this particular slicer, and it's really neat. Shows you the exit codes that are coming from HDInsight, the Linux cluster. So this is my Hive log output. How long it took to run certain stages in my MapReduce job. I can see all of that. And individual stages. Right now it's not too complicated, so it didn't take too long, but it becomes really handy if you're doing performance tuning. What was your question again? I missed it.
Data lineage tracking.
Oh, data lineage tracking. Okay, yeah, I was going to show you. So right now everything is one line. I cannot show you, but if you click on, let's see.
I should just describe the concept, that's good enough.
Yes, it is possible. That is definitely possible. I will try to log into my portal. This is my Microsoft account, and I have a lot more. And I'm going to show you, for instance, a production, not a production, but one of the large prototypes that we have. Here we have a lot more. And here I click on this particular data table and it highlights the data lineage for me. Does it make sense? I click on this guy, it highlights the data lineage for me. I click on this guy, then it highlights everything because everything depends upon this guy.
Right, but this is design time. What I'm talking about is execution time.
Execution time lineage?
Yeah, meaning a row, for whatever reason, something fails and a row doesn't make it to the destination database. It's SQL Server SSIS world.
I see what you're saying.
It can be tracked as the same tracking.
You either push everything or you push nothing. As far as I can think. Yeah. Otherwise, it's going to fail. So it doesn't have the concept of error trapping and saying, oh, this row is out of the delimiter and it's not escaped, so I'm going to ignore this row. I think it's going to fail. HDInsight, I think there's a way in HDInsight that you can ignore the errors, but it's not as robust as what is available on the SSIS side.
But there's still a concept of row because you are using HQL and Hive.
Yes. Yes.
So you can treat it like SQL.
In Hive, yes. That's correct.
As opposed to
Hive is the most, as a SQL developer, Hive is the easiest one that you can pick up in the Hadoop ecosystem, because the syntax is extremely similar to SQL, regular SQL.
Okay, thanks. But that looks like it's something that was. Okay, thanks.
Yeah.
You have the UI, and you also showed PowerShell. Does the UI create the PowerShell script, or is that completely separate?
No. I used to create the I used to use my PowerShell scripts. I create my PowerShell scripts. Go to that one. So everything you see on the PowerShell script is done at the UI at this point. So I don't really need to do anything. Like,
okay,
if you want to create an output table called data table stock raw data, for instance, I had a JSON script, which is the one that I'm copying and pasting, and I can call this particular PowerShell command new Azure Data Table, new Azure Data Factory table, give the data factory name, file name, error action, and force it.
So the UI can create it, but you can modify it.
Yes, I can modify it, or I can create it from programmatically create it from here, or programmatically create it from C# through the web service API. So it's really neat. Yeah.
Well, one, are you going to show us the file?
Yeah, sure.
But the question I had was, so you've got this thing designed, and that's your dev region. How would you script it and deploy it to create another data factory with basically that in it? In other words, a test or a production version.
Okay, this is how I would do it. I would have all my files. Like I can show you how it looks like on my demonstrations, and we did a lot. Like all of these are the POCs that I've created so far. The one that I just showed you is, which one is it? Like this one. So it has got the PowerShell script, which we don't need it anymore. It has got all the JSON scripts. It's got pig scripts. It has got the Hive script. Everything you name it, and you can check in this code to your source control system. Or now, I just learned during this meeting, we said there's a way to templatize all this data factory as a single file maybe, and check in that one, check out that one. Am I right? Okay.
What you have here, you can take it, load it up, then bring up the UI editor, be able to
modify it, yes.
And then change. If you make any changes, though, you can't write it back out into these files, right? So you'd have to make the changes down below, load it up, and take a look at it or whatever.
Apparently, there's a way to do it. I haven't tested, but we said that's
not really
available.
Not two-directional, maintainable between the UI and from.
It used to be even harder. Like I used to switch between multiple windows because the UI didn't have this nice interface to create the objects. We didn't have this particular interface to create these objects. Everything was created through PowerShell scripts behind the scenes.
Yep.
Now they have it, and I'm using it. I like to have error trapping, and it's a little bit easier to do. But you're right in the sense, if I want to check in my code to source safe or source depot type of thing, any kind of a
or if I had multiple developers working,
exactly.
They can't work on the same design. They can't work on the same package then.
No, they can. The whole data factory concept is designed for multiple developers working at the same time in a single data factory. It is mind-boggling, but yes. So I can be creating one pipeline, and somebody else you can be creating another pipeline, and we could all be working together.
And if you happen to try to work on the same pipeline at the same time,
then it might be an issue. Whoever checks in last is going to win.
Or is it going to do collision detection and say somebody else is changing this?
No, I don't think so. At least not at this point.
Okay, then it's very dangerous.
Yeah.
The last one wins, and you don't know.
It is less dangerous than the SSIS world, let's put it that way. In the SSIS world, let's say you have a script task, and you change your script task, there's no way to version that script task.
I totally agree. I mean, I was hoping to get away from the problem that we have in SSIS.
Yeah.
That way.
No, but you can version the package.
Yeah.
You can check out and check in the package from visuals.
Yeah. And you know,
Or
if
the
somebody,
pipeline.
if somebody's checked out the package, you know you can't touch it.
Yeah.
Where here, somebody could actually touch two different, you know, the same pipeline and
Exactly.
blow away each other's changes.
So my operation just completed, and here you can see the file that is created. And it looks a little bit different because this is my directory, by the way. This is my virtual directory. And these are the files that, if you're familiar with the HDFS or Linux systems, this is what you are going to see in near future in Hadoop space. And if you click on it, you are going to see, ignore the first line because I had headers and I told Hive to ignore the first line, hence it creates this new line thingies. But the rest is out there. For January 1996, this was the value. For 1997, this was the value for January, and it goes like that. It just calculated the averages for me. And I can see that fact by clicking on here, and as you can see, they all completed. If I want to go a little bit deeper and see how long it took, I can double click. More, double click. Okay, here we go. It took about 2 minutes, and I can double click on here, and these are the stats associated with it.
So which file did it pick up? You had a, what, 9, 10, and 11 or something sitting there?
It picked up everything, actually, because, oh, I'm sorry, it didn't pick up everything. It picked up whatever the slicer of that day is, but it created the, it overwrites the file over and over. That is the concept that you were asking. So, unlike here, where I have multiple partitions, 9, 10, 11, I just have a single file, single partition, and each time I run my slicer, it just overwrites that partition over and over again. So, what else? I think that was my last slide. So, and we have a couple more minutes, I guess. This is my email address, and here's the YouTube address. I make it a little bit smaller so that you guys can type it up. Otherwise, it becomes a little bit a huge line. And I try to add new videos every week. I do it religiously for the last 6, 7 weeks, and I try to pick the subjects that are really interesting. And I do demonstrations every week to inside of Microsoft, and whatever I demonstrate at Microsoft, I convert it a little bit so that it becomes a little bit more generic and put it on YouTube. And I can show you how it looks like. Oh, should I keep it?
I think it'd be nice to, at least when you're done, just leave this.
Oh yeah, sure. Sure.
Also, if it's okay, they can be put on the Puget Sound SQL Fast website.
Yeah, sure. These are the videos. For instance, this one I discussed the on-demand HDInsight versus bring your own. Here I discussed the running on-premise store procedure, which is not supported at this point through ADF natively, but you can do it, and it's a pretty slick solution. Here I discussed, this was one of my first ones, copy blob to blob storage. Here I discussed the slicers, and I go a little bit deeper. Here I discussed the slicers again. So whatever I demonstrated now today to you guys, it's available on YouTube, and I put it out there. So go back, so you can see right here. Questions, comments? Yeah.
Do you have any demos on there about using SQL?
Yeah. I have on-premise SQL Server.
And is it
full push data?
Is it more of a user interface like SSIS when you're working in the data factory, or you still got all these scripts where you got to define the structure of the file?
It is still scripted, yeah.
But
it's all
JSON
JSON-based.
Scripted automatically. Like if I say use my orders table, is it going to go out there and get it and figure out the structure, or do I have to go in there and tell it what the structure is?
You have to tell it the structure. Otherwise, ADF wouldn't know. anything about your orders table.
Okay, so it's not like SSIS where you point to it, it knows the structure on it.
No, it is not.
That's a little slow.
In SSIS world, it's cheating actually. You click on it and then it knows what's inside of it. Before, and if you change anything behind the scenes, let's say you create the package and then you deploy the package, yet you change anything with respect to that table, all of a sudden your pipeline breaks. Because at runtime, it's going to try to make the pipeline and it's going to break.
Isn't that still true in Data Factory? Because you're defining your structure and now it's changed.
For certain transformation, that is true. For certain transformations, it's not true. You can have structures that are changing all the time, like the unstructured data that we were discussing.
What about SQL data?
In terms of SQL data, it still depends upon how you are treating on the HDInsight side. Like in ADF, for instance, in ADF, I just define my, I can show you that one real quick.
You got to actually type out that structure, and you got 100 columns in there, or is it scripted out for you somehow?
So in ADF, I define this particular table as just 2 columns, but in reality, behind the scenes, it's not actually 2 columns. It has got a lot more columns.
Of course, you could always write a SQL script
Like
to
3
strip out
columns.
the you have. And I do that all the time.
So
Yeah, I was hoping to not have.
Yep. That was like a couple low utility scripts to go and script out schemas and table structures. And you can just plug it right in.
Yeah.
Well, in SQL, you can right-click on the damn thing, get the structure.
Yeah, but this way you can script it out and plug it right into your schema definitions, into your source table and output tables and such.
Yeah. And I bet the product is pretty brand new, and they are, as I told you, they are progressing a lot during the last 3-4 months of the time that I was checking out. And believe me, when I compare to SSIS, the beginnings of the SSIS, that's where we are at ADF, but we are going to be opening up this. Think about SSIS, what was it in year 2002 timeframe? That's where we are at with ADF. And ADF is going to open up your HDInsight, Hadoop clusters, big data for you. So if you're going to invest in yourself, your education, I would say go and learn ADF and Hadoop. Yeah.
In the beginning, did you say AWS, Google Cloud doesn't have something similar at all?
It doesn't have something similar. Yes, that is correct. Google Cloud is way behind. AWS is the market leader at this point. Azure is coming second, but AWS has probably 8 times, 9 times more deployments than Azure at this point. And ADF doesn't support AWS, but when I was talking with the ADF folks, I suggested, hey, why don't you guys support Azure as well, Amazon as well? Because that's where the market is. And ADF should be totally agnostic, to be honest with you, so that it can support anything, anywhere, and as long as it can orchestrate, I'm good to go.
So you want ADF to be the big killer?
Huh? Yeah.
You want ADF to be the big killer?
Yeah, exactly.
Because they used to do ETL on the
HDInsight? No, ADF is actually working with Pig too.
Yeah.
Pig is one of the technologies that ADF can interact with. It depends upon what's your personal preference. It can interact with HBase, Pig, Hive. Those are the technologies that I know of that supports ADF. It can also interact with machine language algorithms, which I can go through. But and you can write your own .NET activity if you want to interact with HDInsight through ADF.
So what I was saying is in the open source Hadoop side, you need Pig to do ADF. Right? If you have ADF on this side, you don't need to do any other coding.
It depends upon how you use it. Yeah.
Okay.
Yeah.
I get you.
No problem. And believe me, it's a complementary product. It's not a killer for Pig. Yeah. Like you cannot pull data from on-premise to cloud side using Pig. You need to use Scoop and make it happen. And it's really cumbersome to make it happen. I've done it before, and it's a nightmare. Yeah.
Can you talk a little about the validation that it does do? One of the keys in some of the basic overviews is about how it validates that the data has moved correctly and things like that.
I see. Right now it doesn't support it, ADF. The only thing that I can see that in terms of data validation is you click on the schema and you can see the schema of it. But it doesn't tell you.
I'm sorry. The source and target, it's moving a blob from one place to another. I thought it ensures that the blob has an accurate copy has been made. I thought there was validation in the project.
So right now when you define a table, in the table definition, there's a section called policy. What you can validate against, right, would be you want to validate that the file that you want to move is of a minimum size, or if you're talking to a relational database, there's a minimum number of rows before you even start the copying process. That's one part. Policies you can impose when you declare the tables. The other part would be if you do the right slices based on what Jen has done, then end to end you could have a starting slice that is ready. That causes something to run. It produces an output slice. And then it goes all the way down to the final slice. Now, if one of these final slices fails, right, then you can trace back to say, oh, well, this failed because of this process. And if you drill down to this process, you say it failed because the input was not ready. So from the diagram, you can see that over the next few months or so, the monitoring management experience, right now we have a very modest monitoring management experience. A few months from now, this monitoring experience is going to evolve really, really rapidly. That could address some of the things that you have in mind.
Any other questions? How about you guys?
Way above.
Oh, believe me, you guys are going to catch up pretty quickly. Go ahead.
One on the slices for instance, you're doing the stock price and you want them every hour. Where's that being stored temporarily? Because it's only going to load it to the target location once.
Yeah,
so
awesome question. Yeah, it is going to store it right here. My raw data is here. My hourly data is right here. I think this was my hourly data. Let me see.
So that's being stored at your server, not locally.
Yeah, everything is on the whatever your destination table is. Let's say if you set your destination to be an on-premise SQL server, it would have been storing data on on-premise SQL server. If you store it on Azure SQL, it would have been in a table in Azure SQL. If you store in Blob storage, it's going to be over there. But think about it this way: like this guy can be running every freaking hour. But the next guy can be just running once in a day and get everything. And if there's something wrong with 24 slicers, let's say one of them fails, the next one is not going to run. It's just going to wait until all those 24 are available. Because that is the slicers, ADF knows that those are the slicers that it needs to pull. If it cannot pull, either you take all or nothing. That's how they keep the eventual consistency alive.
Is that like a publish and subscribe model?
I wouldn't call it a publish subscribe model, no. No, I don't think so. Let me see. Like, think about it this one.
Dependency model.
Yeah, dependency model. Like, these guys might be running by the minute. And this guy can be running hourly, but this one, the final one, just might be running once in a week. But in order to run that once in a week thing, all these things need to run properly for a week during their own slicer time frames. Otherwise, it doesn't run. It's going to give you an error message, and the last one is going to wait until that error message has disappeared. In other words, you come and you run it, you fix something, and you run it again. Good question. You guys are listening. Yeah.
Okay, so we've got your YouTube videos. How did you learn this stuff, or where's another good source to learn this?
I was lucky. I was bugging the heck out of.
Besides having a buddy over here.
Exactly. Well, most of the time I use the the online tutorials that are already available on the Azure ADF website, like Azure Data Factory. Here's the, and they have really good documentation. Believe me, they did much better than most of the and they use GitHub if you want. And here you can have the ADF walkthrough. This is what I did at the beginning. And if you want, you can see the README file. I know it might be, this experience is totally different in terms of a person who's coming from Microsoft world, but the rest of the world is using GitHub, and the rest of the world is open source guys are using GitHub. And so I salute the ADF guys that they are embracing the open source platform. And believe me, it's really important for you guys not only use Microsoft, but also learn the open source platform. And Hadoop, especially, that's where the money is. If you want good jobs, good paying jobs, go for Hadoop. So, did I answer your question?
Yeah.
They have also the object model is also defined somewhere. The pricing, MSD, and contents. And they have a form. Oh, here's the object model. The whole object model is right over here. So whatever I described, like link services, here's how you define the link service as a generically. And then if you want to define an Azure storage link service, this is the Blob storage. This is what you need to do. Here's the example. This is what I did just a minute ago. My account name, my account key. If I want to do the on-premise one, this is what I need to do. This is JSON script, and here's an example of it. For Windows authentication. This one is for SQL authentication. Yeah, for one of them is SQL authentication, the other one is Windows authentication. So it supports both. Good question. Any other comments, questions? Well, thank you. As I wrote my email address, feel free to ping me. And thank you for coming.